On July 1st, 2025, a telescope in the mountains of Chile caught something it was not looking for, a single point of light, moving at a speed that did not belong to anything born in this solar system. Within 72 hours, without any public announcement, without a press conference, without a single word to the outside world, NASA and ESA began quietly redirecting their most powerful instruments toward that one point in the sky. Hubble turned, Webb turned, 9 separate space missions, each built for a completely different purpose, all pointed at the same tiny object at the same time. Nobody outside a small circle of astronomers was told why. That object is called 3I/Atlas. And what China just discovered about it has confirmed something that the mainstream scientific community has been quietly trying to avoid saying out loud. To understand why China's new data changes everything, you first need to understand what 3I/Atlas actually is. The designation tells you the most important fact. The I stands for interstellar. This object did not form in our solar system. It was not born around our sun. It did not come from the Oort cloud or the Kuiper belt like every comet or asteroid you have ever heard of. When astronomers traced its path backward through space, the trajectory refused to curve into a solar orbit. It followed a hyperbolic path, unbound by our sun's gravity, passing through only once and never returning. This is a visitor from another star system entirely, from a different part of the galaxy, from a sun we have never seen and may never be able to identify. Every planet, every moon, every comet that humanity has ever studied has been a permanent resident of this solar system, locked in orbit for billions of years. 3I/Atlas is not a resident. It arrived from outside, it passed through, and it has now almost completely disappeared back into the dark space between stars, never to be seen by human eyes again. The speed of this object is what forced every major space agency to act immediately. 3I/Atlas was moving through the solar system at roughly 60 kilometers per second, relative to the objects around it. That is more than twice the speed of our fastest rockets. There was no decade to plan a mission. There was no year to build new instruments. Scientists had a few months before it passed too close to the sun to observe, and then a few more months before it vanished into the outer solar system for good. Every observation had to happen immediately or not at all. So the machines went to work. Hubble captured it first. Images from the Hubble Space Telescope revealed something that immediately stood out. The solid icy nucleus at the heart of 3I/Atlas was smaller than a kilometer across, a modest chunk of ancient ice and rock by cosmic standards. And yet it was generating a glowing cloud of gas and dust called a coma that stretched to roughly twice the diameter of Earth. A single object smaller than most cities was wrapped inside a haze larger than our entire planet. On July 21st, 2025, Hubble captured that haze in detail, a teardrop-shaped cocoon of dust streaming off the nucleus with the comet moving so fast that the background stars themselves streaked into lines behind it. This was not a still photograph of space. This was a visitor moving too quickly for the universe to hold still around it. Then James Webb entered the story, and this is where everything started to unravel. On August 6th, 2025, the James Webb Space Telescope turned its near-infrared spectrograph toward 3I/Atlas. This instrument does not simply photograph objects. It reads their chemical fingerprints, it breaks light apart, and identifies exactly what a distant object is made of. What Webb found should have been routine. It was not. The telescope revealed that 3I/Atlas has one of the highest carbon dioxide to water ratios ever recorded in a comet. Every comet humanity has ever studied in detail is dominated by water ice. This one was different. This one was overwhelmed by carbon dioxide. The ratio was so unusual that astrochemists immediately flagged it as something that did not match the formation conditions of our own solar system. The interpretation was stark. Either this object's ices were exposed to radiation levels far higher than anything comets in our solar system have ever experienced, or it formed at a location so cold, around a star so different from our own, that carbon dioxide itself froze solid before water ice could even begin to form. Either way, the conclusion pointed in the same direction. This object did not grow up anywhere near a solar system like ours. It grew up somewhere colder, older, and fundamentally stranger. But Webb was not finished. In a follow-up study, researchers went looking for something that most people would overlook entirely: the ratio of two versions of carbon buried inside the comet's chemistry: carbon-12 and carbon-13. This is not a detail scientist's chase for curiosity. Carbon-13 enrichment builds up slowly inside stellar systems over time. The more time an object spends near a star, the more carbon-13 it accumulates. When Webb analyzed the data from 3I/Atlas, the result was striking. The object showed almost no carbon-13 relative to its lighter counterpart. The researchers interpreted this as evidence of extreme age. Not thousands of years, not millions, billions. The team now believes 3I/Atlas could be as old as 12 billion years. Our own solar system is roughly 4.6 billion years old. This object may have already been ancient before our sun even ignited. It may have been drifting through interstellar space since before the Earth existed, since before life began on this planet, since before the conditions that would eventually produce our solar system had even assembled. Sit with that for a moment. A 12 billion year origin would place the birth of this object during what astronomers call cosmic noon, the peak era of star formation in the early universe, the period when galaxies were generating new stars at rates that dwarfed anything happening today. 3I/Atlas is not simply from another star system. It may be a physical, tangible remnant of the galaxy's own youth, a frozen time capsule that has been traveling through interstellar space for longer than most stars we can see tonight have existed, and prior analysis of its trajectory indicated it came from the Milky Way's thick disk, an ancient population of stars far older than the region where our own sun was born. Everything about this object's chemistry, its age, and its origin points to the same conclusion. This is not a cousin from a neighboring star system. This is an outsider from a completely different chapter of the galaxy's history. Then China's new data arrived, and the anomalies stopped being subtle. Chinese observatories, using independent instruments and separate analysis pipelines, confirmed something that had been flagged in earlier Western datasets, but had not been emphasized publicly. The deuterium content of 3I/Atlas is not simply unusual, it is extraordinary. Deuterium is a heavier version of hydrogen. The ratio of deuterium to regular hydrogen in water and methane is a signature that reflects the conditions under which a molecule formed. In our solar system, this ratio falls within a well-understood range. In known comets, in meteorites, in the planets themselves, the numbers cluster in a predictable band. 3I/Atlas sits nowhere near that band. The object displays a deuterium fraction, showing roughly 1 deuterium atom per 100 hydrogen atoms in its water, and 1 in 30 in its methane. Abundances up to 1,000 times above the average cosmic level, more than an order of magnitude higher than in any known comet or meteorite in our solar system. 3 orders of magnitude higher than in methane found on solar system planets. China's independent confirmation of these numbers removed any possibility that the original measurement was a calibration error. The numbers are real, and numbers like that do not appear in nature without an explanation. Right now, nobody fully agrees on what that explanation is. The structural anomalies followed, and this is where the scientific community split completely. New images from the Hubble Space Telescope, taken on January 14th, 2026, appeared to show something unexpected near the comet's nucleus. 3 jets of material, arranged with a geometry that observers described as striking, each separated from the next by an angle of exactly 120 degrees. Natural cometary outgassing, driven by an irregularly tumbling surface heated unevenly by the sun, tends to be messy, chaotic, unpredictable. The jets emerge from whatever parts of the nucleus happen to be exposed to sunlight as the object rotates, and they spray outward in patterns that reflect that randomness. A perfectly symmetric 3-point arrangement, 3 jets separated by exactly 120 degrees is not what you expect from a lump of ancient ice-venting gas as it warms. An anti-tail was also documented, a spike of material pointing directly toward the sun rather than away from it, which standard cometary physics does not predict. Harvard astrophysicist Avi Loeb, who had been publicly arguing that interstellar objects deserve more scrutiny than mainstream science had been willing to give them, looked at all of this and said something simple. Nature rarely produces this kind of precision by accident. The scientific mainstream pushed back immediately. Jason Wright, an astronomy professor at Penn State who has repeatedly challenged unconventional interpretations of interstellar objects, argued that the object was behaving exactly the way an irregularly shaped natural comet should behave. Messy, unexpected, and driven by nothing more exotic than sunlight hitting ancient ice at odd angles as the nucleus tumbles. The City Institute and the Breakthrough Listen project scanned 3I/Atlas across a huge range of radio frequency, searching for any artificial signal. The result was silence. The most sensitive radio telescopes on Earth, specifically pointed at this object and searching for any transmission it might be producing, found nothing. 2 completely different camps. The same data, opposite conclusions, and the object was already leaving. By late April 2026, 3I/Atlas had traveled to a distance of roughly 1 billion kilometers from the sun, more than 6.5 times the Earth-Sun distance. The window for direct observation, already narrow, was closing permanently. China's new data arrived in this final window. Independent confirmation of the deuterium anomaly, independent confirmation of the unusual carbon chemistry, and something the original Western analysis had not fully resolved. A measurement of the object's outgassing rate as it receded from the sun that did not match the models built using any known comet from our solar system. The rate at which 3I/Atlas was releasing gas as it cooled and moved away from the sun followed a curve that sits outside the distribution of every solar system comet astronomers have cataloged. Not dramatically outside, but consistently, measurably, and reproducibly outside. China's team ran the analysis 3 separate times with 3 different instrument calibrations. The result did not change. Something about the way this object loses material as it moves through space is different from anything born here. The implications of that finding are still being debated, but the debate itself tells you something. When China's confirmation arrived, the scientific conversation changed. Previously, researchers could argue that any single anomaly, the unusual carbon ratio, the symmetric jets, the deuterium levels, the anti-tail, might have a natural explanation specific to that measurement. When an independent space program running independent instruments in independent facilities confirms the anomalies using separate data pipelines, the threshold for dismissal rises sharply. This is not one team seeing something strange. This is 2 entirely separate scientific communities looking at the same object from different angles, using different telescopes, and arriving at the same result. The numbers are real. The anomalies are real. The question of what they mean remains open. Avi Loeb, the man who had spent a year insisting this deserved serious scrutiny, offered a careful reassessment when the Chinese data became public. He noted that the cumulative picture, age, chemistry, structure, outgassing behavior, placed 3I/Atlas in a category that no prior object had occupied. Not confirmed artificial, not comfortably natural, something sitting in the space between those descriptions where the data does not yet have enough resolution to force a verdict. He tempered his own earlier position while maintaining that the question was not closed. That is not a triumphant confirmation. That is a scientist recalibrating in public, acknowledging that the mystery has not resolved cleanly in either direction, even as the object disappears. Here is what China's discovery actually confirms, stripped of everything except what the data shows. 3I/Atlas is chemically unlike any object ever studied in our solar system. Its age places its formation in a period of cosmic history that predates our sun's existence. Its structural behavior, confirmed independently by separate observatories on separate continents, falls outside the distribution of known natural comets, and its deuterium content, now independently verified, is 1,000 times higher than the cosmic average in ways that current models of natural formation cannot fully account for. None of this proves it is artificial. The radio silence from Breakthrough Listen's most sensitive instruments is real and significant. No signal was found, no transmission was detected, but the absence of a radio signal does not resolve the chemical and structural anomalies. It eliminates one specific hypothesis. The data itself remains. 3I/Atlas is now almost beyond the reach of every telescope on Earth. It is heading back into the interstellar medium from which it came, carrying whatever answer it actually holds, and it will not return. Not in any human lifetime, not in any civilization's recorded history. The next interstellar visitor is already out there. Astronomers expect the upcoming Vera Rubin Observatory to detect dozens more objects like this one in the coming years. Each will arrive on its own trajectory, carrying its own chemistry, its own age, its own unanswered questions. 3I/Atlas was simply the first one we were prepared enough and lucky enough to watch properly. The first one where two independent space programs pointed their best instruments at the same target and compared notes in real time. The first one where China's confirmation changed the weight of the anomalies from interesting to undeniable. The mainstream says comet. The dissenting data says something that does not fit neatly into word. And the object itself, the only witness that actually knows, is fading into the dark it came from, leaving behind exactly what the universe always leaves behind when it shows us something we are not yet equipped to understand. Data, silence, and a question that will outlast the observation window by a very long time. Consider the full arc of what happened here. A year ago, before July 2025, humanity had confirmed 2 interstellar visitors in all of recorded history. Oumuamua in 2017, Borisov in 2019. 2 objects, 2 data points, not enough to establish patterns, not enough to say with confidence what interstellar objects look like, how they form, what chemistry they carry, or how they behave as they pass through a solar system that was built differently from whatever system produced them. 3I/Atlas changed that, not because it resolved the questions that Oumuamua raised, because it gave scientists an object they could actually study, larger, slower, and available for long enough that multiple agencies, multiple instruments, and multiple independent teams could all gather data before it disappeared. And what those teams gathered, taken together, paints a picture that is genuinely without precedent, an object born before our sun existed. Chemistry that places its formation in an environment nothing like our solar system. Structural behavior that falls outside every statistical model built from the comets we have observed over centuries. Deuterium ratios confirmed independently by a completely separate space program using completely separate instruments. This is not a single anomaly that might be explained by a calibration error. This is a convergence of independent anomalies, confirmed by independent methods across independent institutions on different sides of the planet. The scientific process is supposed to resolve questions like this through replication and convergence. When separate teams following separate methods arrive at the same result, confidence increases. In this case, the separate teams are arriving at the same anomalies, the same departures from prediction, the same numbers that sit outside the range of everything born in our solar system. What that means for the question of what 3I/Atlas actually is has not yet been resolved. But what it means for the question of whether the anomalies are real has been answered. China's confirmation answered it. They are real. The timing of China's new data release deserves attention on its own. Scientific data from interstellar objects is, by convention, shared internationally through open access publications and astronomical databases. The 3I/Atlas data has moved through those channels. What China's team released was not a challenge to Western findings. It was an independent replication, a separate set of measurements using different instruments processed through different analytical pipelines, arriving at results that align with the anomalies flagged by the original detection team. In science, that kind of independent replication carries enormous weight. It is the difference between a result and a finding. A single team measuring something unusual is interesting. Two completely separate programs measuring the same unusual thing using different tools is something harder to dismiss. The mainstream scientific community's response to China's data has been careful. Acknowledgement that the measurements are consistent, continued insistence that natural explanations remain viable, and a notable absence of the confident dismissal that characterized some early responses to the anomaly reports. That shift in tone is worth paying attention to. Here is the question that China's confirmation forces into the open. If the anomalies are real, confirmed independently, measured by separate instruments consistent across separate analytical teams, then the burden of explanation has shifted. It is no longer enough to say that natural explanations are possible. They must be demonstrated. A specific natural process must be identified that would produce 1,000 times the cosmic average deuterium enrichment, combined with the observed carbon chemistry, combined with the structural jet geometry, combined with the outgassing behavior that falls outside the distribution of all known solar system comets. That natural explanation may exist. It may be found as more data is analyzed and more models are tested. Science has a long history of finding natural explanations for things that initially seem to defy natural explanation. But right now, that explanation has not been demonstrated. The anomalies are real, and the mechanism to account for all of them simultaneously has not been identified. 3I/Atlas is leaving. The data is in. The question is open. And somewhere beyond Jupiter, moving at 60 kilometers per second toward the dark space between stars, the object that raised these questions is carrying its own answer away from us forever. The next one is coming. The instruments are being built. The questions are sharper than they were a year ago. Whether we will be ready to recognize the answer when it arrives is the question that outlasts this particular object. And it is the question that China's confirmation, more than any other single piece of data from this entire story, has made impossible to ignore. There is one final detail that most coverage of this story has completely overlooked. Loeb submitted a formal white paper to the United Nations addressing the potential implications of interstellar objects that might carry technology not of natural origin. Whether you find that credible or not, the fact that this argument reached a formal international body tells you something important. The conversation has escaped the boundaries of a normal scientific dispute. It has entered the space where science, policy, and the question of what humanity does with genuinely uncertain information begin to overlap. A congresswoman visited Loeb's office at the Harvard College Observatory. Public figures in American politics began weighing in directly. Discussions about releasing government files on unexplained aerial phenomena entered the same news cycle as data from a comet discovered by an automated telescope in Chile. A rock passing through the solar system somehow found its way onto the desks of national politicians. That trajectory, from a faint point of light in a routine sky survey to the floor of the United Nations and the offices of elected officials, says something about where this story sits in the public imagination. Not because the politicians have anything useful to add to the spectral analysis, but because the anomalies are real enough and confirmed by enough independent sources that people in positions of authority are no longer comfortable treating it as purely an academic matter. China's confirmation did not create that situation, but it deepened it, because independent confirmation from a second major space program means the data can no longer be attributed to a single team's methodology or a single instrument's calibration. The anomalies are not an artifact of how one group of scientists chose to analyze their measurements. They are a feature of the object itself, showing up consistently across different systems built by different people in different countries asking the same questions. That is what confirmed means. And that is what makes China's announcement different from everything that came before it. The mainstream calls it a comet. The data calls it something that does not fully fit that description. And the object itself is gone, carrying the truth with it into a darkness that no telescope we currently possess can penetrate. The next interstellar visitor is out there. The Vera Rubin Observatory is being brought online. The questions are sharper. The instruments are better. The international scientific community, for the first time in history, has a playbook for what to do when something arrives from another star. Whether the next arrival will answer what this one left unresolved, that is the question that China's data has left hanging in the air, confirmed and unresolved at the same time, exactly the way the universe always leaves its most important questions.